Let's start with platform dependency and independency. Now, independency is something like a handheld console, like a 3DS, 2DS, PSP, stuff like that, and phones and tablets. You see, they don't require any kind of other hardware to run properly, because they got the face buttons here, and the D-pad, the buttons, start, pause, home. The screen is built in, and you got like since the 2DS and the 3DS come with a stylus, L and R buttons, shoulder buttons, and stuff like that. They don't require any other hardware to run properly, but they do supply hardware that can help with playing games, such as the CirclePad Pro, which is only compatible with the 3DS, and I think the 3DS XL. But since Nintendo released another one, they don't require that. When on the other hand, platform dependency, like a computer or a Xbox 360, require things to run optimal. With the PC, you require monitor, and you also require like something like headphones or speakers. But then you've also got you've also got to get other cables, like you can see at the back of here. You also need Ethernet cables to connect to the internet, stuff like that. You need other pieces of hardware to run this thing in optimal conditions. Now, platform dependency is basically is not more cost efficient. It's actually worse. When with like independency, you got like the wire and stuff like that. You just need a charger for your device, and then you can just go ahead and play games like this. I'll have more about platform independency in a moment. Now, with other consoles like the PS3 and the Wii U and the Xbox 360 require a controller. Now, I only own an Xbox 360, so the controller is basically like a peripheral device needed to play games. Because if you don't have a controller, that's it. And these are very dependent, because if you don't have one of these, what are you going to control the game with? Unless you've got a Kinect. And if you do have a Kinect, then you're obviously not looking for a good time. But it's more reliant on these. You can get wired ones and wireless ones, even custom made ones, but Xbox 360s, PS3s, and Wii U's are more dependent on a controller. But if you have a leaded one, it can be compatible with the PC. But main thing is that Xbox 360, PS3, Wii, and all that, and PS4 and Xbox One require a controller to work properly, but a controller gets built in. It gets sent with the console, but if it breaks, you're going to need another one. But also, platform independency also means, is it backwards compatible? Is it backwards compatible with all video games? Now, with the 3DS, 2DS, 3DS, all those that Nintendo released, backwards compatible with all DS games, only with a minor change to the screen. Now, with the DS, that was backwards compatible with all Game Boy games until the Nintendo DSi came out and they removed that. Now, with the Xbox 360, same. The Xbox 360 can play Xbox games, but needs to be updated, sadly. And if you don't have the game, and if the game isn't updated with the system, then that's pretty much tough luck, innit? You can't. Sorry, not tough luck. It's kind of bad, because you won't be able to play that game. So that's more dependent on if Microsoft deem it proper to actually create a update for that particular game, or bundles of games. Now with PS3, this kind of was strange. The first PS3 was backwards compatible with all PlayStation 1 and all PlayStation 2 games, then the Slim came out. The Slim removed all backwards compatibility with the PlayStation 2 games, but not PlayStation 1, and then the top loader one, which was like sorry, not top loader, the one where you had like a disc tray, that removed backwards compatibility with all PS1 and PlayStation 2 games. It was only compatible with PlayStation 3. Xbox One and PlayStation 4 are not compatible with any. They're not backwards compatible at all with any previous games. unlike with the Wii U, which is backwards compatible with all Wii games, and the Wii was backwards compatible with all GameCube games. And that's pretty much with what that was. But with PC, backwards compatibility isn't a problem, because if you want to play a game that was originally released with Windows 95 and it doesn't work with Windows 7, chances are a modern community would have already developed a fix for this type of game. With Doom 3, if you wanted to run it at widescreen and you couldn't figure out how, you would be able to use the config file to basically configure it to that screen. That tutorial will be part of this video very soon, when I can get perhaps booted up. Same with Exceed Gunbullet Children. That game only ran at like 15 frames a second, but with some smart coding and with the Windows compatibility tool, you can actually get that thing to run at 60 frames, which makes the game 10 times as harder. But again, that tutorial will be in the game. I will show you a couple of tutorials in this video through how to do those kinds of things, because backwards compatibility with PC is a lot easier than backwards compatibility with any consoles. I will also show you how to get Manhunt to run pretty well. I will continue recording when I get more information. I've got more information. The laptops, like gaming laptops, like Alienware's, and well, basically normal laptops, they're also independent. They don't need any kind of like device to run well, because they got inbuilt speakers, they got like an inbuilt mouse pad and an inbuilt keyboard. But then again, you'd want an external mouse. But for PCs, if I just move these out of the way, as you can see, with a mouse, with like a computer, you'll need a keyboard to basically do your typing things with, and a mouse. And you can't get these with the PC unless you've bought a pre-built one. If you build one yourself, you're gonna have to rely on yourself to buy a keyboard. And if you built one yourself, you probably want to go with something that's good, like Corsair or Razer. But these you can pick them up for like 20 quid. But again, it's not independent. They depend on different pieces of hardware to run correctly, and that can get quite costly. But with game consoles that are independent, like the 2DS and the 3DS and the PSP, like I've said before, they're more cost efficient because they don't require anything else to run other than a power supply, which comes with the console, which is a charger. But with PC, Xbox, and all those types of things, those are not independent, they are dependent. That's pretty much all I've got for platform independency and dependency. I will be putting in on how to get games like Doom 3 and all those types of games to run on a Windows 7. That'll be part of the platform independency. Well, dependency. That's all I've got for platform dependency and independency. The next topic will be operating systems, which will be part of this video. I'm now going to speak about the OS for gaming platforms. Now there are various ones, like the Xbox One uses a Windows 8 based operating system named Xbox OS, which is the main parts of Windows 8, but it's just as confusing and as difficult to navigate with a controller. It also registers voice and face recognition to launch games easily, but it was made for mainly voice navigation rather than the controller navigation. Me personally, I have used this. It doesn't work as well as it should. I mean, yes, it does register the input very well, but when you're in the store and you can't find out what to do, there's nothing that you can really do about it other than use the voice commands for the Kinect. And as far as I'm concerned, if you didn't remove the Kinect, half of your availability of using it would probably be lost. But trying to navigate through the store was harder than it looked, and trying to back out of a game was even more harder than it looked. The OS for Windows 8 didn't quite work as well as it should have done. Now, when people look at the PS3, they think console. but not according to this webpage made specifically by PlayStation. And they specifically said that the PlayStation 3 is more than just a computer entertainment system, because it runs on a Linux operating system, which is part of the Unix family, so obviously they went with the open source route. But they also released things that you can basically use on the PS3, such as Yellow Dog Linux, OpenSUSE, Fedora, and Ubuntu, which I've explained before. And these respective websites do come with installation, but as they've said that if you install these, you can plug in your keyboard and mouse and play and use it as an entry level PC, which is pretty good. I mean, that's one way to get gamers into getting into PC gaming already. Plus, Sony haven't really been that meant to be evil towards a PC gaming community, which is good. And the OS itself is Unix based, which, to my knowledge, is actually really well made. So that's pretty much everything I have on PS3. The PS4 has an interesting named OS called Orbis, and is a modified version of FreeBSD 9.0. Now, it's kind of strange for Sony to release something called Orbis, but one thing to be said is that it's Unix based, again, Linux, and the console itself is using an AMD 8-core APU and a Radeon GPU cores, and there isn't a Catalyst driver available for any BSD operating system, so I'm guessing that they took BSD, modified it heavily to create Orbis to run with the AMD 8-core APU and Radeon GPU cores, which again, Sony are really good at this. But with Orbis, I haven't used it personally, and I've seen it being used. It isn't that convoluted, and it isn't that bad. I mean, from what I've seen of it, it's actually easy to use, very user friendly, and the OS itself seems to run very well on the PlayStation 4. And as I said before, it was specifically made for AMD hardware for the PS4 to run well, and was made from the ground up with a not ground up, but using a pre-built one which was FreeBSD, and then modifying it to basically be used as Orbis. And they also pulled it from the PS3. They used some of the other OS, some of the features of the PS3, put it onto the PS4 as part of Orbis. That's what I've got for PS4. Now, with Nintendo devices, they don't like to release their system software about what it is. Now, I don't have a lot of about the Wii U or the 3DS running softwares, but what I do know is that it's closed. They actually create their own OSs for their own devices. And honestly, I've used the one on the 3DS, not as convoluted as everyone would say, and it's actually quite nice. Now, I can't find anything on the on it itself, but I'll try my best at this current time to try and find something about it. I found something here, I'm not sure if it'll actually tell me, but it says here that the operating system runs on a separate CPU called the I/O processor. Because of this, the Wii U operating system does not take up resources from the main IBM CPU, of which 100% can be dedicated to the game's software. When a game is running, the OS is off and does not require any system memory. This means the game's software can utilize 100% of the RAM, unlike other consoles which usually reserve 5 to 10% of the RAM for the OS at all times. Now, thinking about that, I've used the Wii U once, and to be honest, I've seen it being used by others. That's actually quite true. The games do run swimmingly because they basically make sure that the OS isn't taking up any of the RAM, and all of it goes to the game to make sure that the game runs well. So Nintendo has actually created an operating system that works well with the console, as well as working well for the games. Basically making it a very good way of getting gameplay to the player without them having to feel, you know, like having to experience lag at times. So more built for the player rather than it just built for the console. Now with PC there are multiple types of OSs that you can choose from. We have the Microsoft Windows, which is what everyone uses, Linux, which is just starting to grow, and Apple Mac OS. Now, Windows is much more easy to use and a lot less confusing and better for gaming, because developing a game for Windows is a lot easier and is the most popular. Most of the games get released for PC will have no problem on Windows, which is actually quite true. I mean, yes, games do get developed for Mac, but as people have discussed, that Mac isn't really for gamers. Windows is, because Windows is just far more powerful and can handle the games. As with Linux, Linux, like I've said, has just started to grow, and the operating system is also open source, which means that anyone can create their own type of OS from the Unix family. And it also has different, it's also been used for different things like wristwatches, laptops, and supercomputers, etc. And because it's open source, you can create whatever you want. I mean, the one that most people would probably use is Ubuntu Studio, which is more for sound and design. Or what Valve is trying to do is to create an operating system that is made purely for games, which has already started to make its way through community with Steam. As for Mac OS, this one's the least used. Compared to games, it's a lot harder for games to be configured for it, because of it being rather underpowered compared to Windows PCs, because the Mac OS was specifically built for sound and video rendering rather than PC gaming. Mac doesn't appeal to gamers because of the price, as well as it's more expensive than the PC. Apple Macs are just not meant for games. I agree with that, because I actually have that as a quote from somebody on Gaming Biz. He says that like Apple Macs aren't just not meant for games. I completely agree with, because the mouse is not very good and neither is the keyboard. And Apple Macs is purely made for video and music creation rather than playing games. This is actually true because no one wants to configure a game for a Mac, and then people say like can make games for Macs because of college students. I say don't, because college students wouldn't play games because they're at college. But nevertheless, Mac is the most weakest out of the three. Now, graphics card driver, depending on where you've bought your graphics card from, for example, AMD or Nvidia, they would have drivers on their website for the particular GPU. Now, a graphics card can work with the drivers, but only in 2D mode. Now, in order for 3D mode or for stuff like PhysX to work, they would need the drivers, which can also help the device itself cope more at optimal temperature and, for example, remain with optimal performance on a game. Now, a graphics card driver basically prevents any kind of glitches to happen, or maybe some kind of RAM leak to come through. And a typical example of this would be the AMD Catalyst. Now, the AMD Catalyst would require a new one every couple of months, because there are some things that have been updated to the graphics card that maybe needed checking, and you would need to get to the website to download an updated version of Catalyst Control Center. And that's pretty much how graphics card drivers work. They have particular features, like with AMD, you've got the Omega, which it does have a few interesting features, such as being able to up the 1080p up to 4K without having any distortion of picture. Or with NVIDIA GeForce, you have PhysX, which is a special kind of physics system implemented into the game if chosen by the developers. So both sides have different drivers, and both sides have different features for those drivers. Drivers are completely free if you bought a AMD or NVIDIA graphics card. AMD can work with PhysX but can't use it, but you still need PhysX for certain games to work if it requires PhysX. That's all I have on GPUs. Next up would be the network interface that these kind of things use. Okay, I'll be explaining sound card drivers now. Sound card drivers are basically what's required for a sound card to work. Say like if you got like a sound card that was specifically made for a specific application, you need to download that from their website, but there are free ones like Realtek. Now, a sound card is basically not onboard audio.
you can buy devices that have onboard audio with them, but a sound card is specifically something else that can increase the sound and make things sound better, making a more crisp sound than usual. And it's also been color coded with pink, which is an analog microphone audio input, light blue analog line level audio input, lime green analog line level audio output for the main stereo signal, which is for front speakers or headphones, orange analog line level audio output for center channel speaker and subwoofer, a black color, which is analog line audio output for surround sound speakers, typically rear stereo, silver or grey for the analog line level audio output for surround optional side channels, brown or dark for analog line audio output for a special panning right to left speaker, and gold or grey for game port and MIDI. Now, these are like the typical things that you'd expect from a sound card. Typical things that you want for PC gaming as well as normal gaming. I'm not sure if any consoles do have well, of course they would have onboard audio, but I'm not sure if they use the same kind of output. So I'm pretty sure maybe it got, because HDMI actually transports audio along with it rather than just a picture. So I'm guessing that's how the Xbox 360 and the PS3 does it. But as for PC, I've just explained how PC do it, and to be honest, sound cards are very expensive to come by, and the drivers are free on the website as long as you have the device required. That's all I have about sound cards. I will speak about graphics card drivers next. A network interface controller is also known as a network interface card, network adapter, and a LAN adapter. It's a piece of hardware that you put in your computer, and it essentially connects via any type of connecting, like any kind of connecting things like USB, Wi-Fi, Ethernet. Basically, anything that can connect something up to something else is technically a network interface controller. And you can buy one that's integrated, or you can get one that's or you can buy one that's completely dedicated to these types of things. And they have programmed input and output, direct memory access, and it's just used for performance and it also says that multiple NICs provide multiple transmit and receive queues, allowing package received by the NIC to be assigned to one of its receive queues. It's basically anything that goes from the modem through to the NIC, which is connected via a Ethernet cable. So anything that connects to any other type of hardware is essentially an NIC, or network interface controller. Okay, now we are on to Microsoft DirectX. Now, Microsoft DirectX is a collection of application programming interfaces, API, for handling tasks related to multimedia, especially game programming and video on Microsoft platforms. So you'll find this on almost any Xbox or PC for games. That's just a given. It will be there. It all began with Direct, such as Direct 3D, Direct Draw, Direct Music, Direct Play, Direct Sound, and so forth. And you might notice that that the initial X has been carried forward in the meaning of API's design for the Xbox, such as Zin Input and the cross-platform audio creation tool XACT. While DirectX pattern has been continued for Windows APIs such as Direct 2D and Direct Write, and Direct 3D is also widely used for the development of video games for Microsoft Windows, Sega Dreamcast, Microsoft Xbox, Microsoft Xbox 360, and Microsoft Xbox One. So anything that ran with a Windows interface. Sega Dreamcast ran with the Windows CE. That's why it was supported by Direct3D. Direct3D is part of the DirectX, but the DirectX is also a software development kit, which is abbreviated to SDK, consists of runtime libraries in redistributable binary form, along with accompanying documentation and headers for use in coding. Whenever you install a game on Steam, you will notice they will say installing DirectX. That's if it's been if it uses DirectX, and a lot of games do use DirectX, and the new DirectX is going to be on Windows 10 only, which is kind of bad on Windows part. But they are mainly used for purposes of gaming rather than anything else, and I've seen almost every game use this type of thing, because I play a lot of PC games, and there are a lot of them that require DirectX, and honestly, it's not a bad thing. I like DirectX. DirectX is actually quite nice. And it's also, but continuing onward, the SDK is available as a free download, while the runtimes are proprietary. Closed source software source code is provided for most of the SDK samples. Starting with the release of Windows 8 Developer Preview, DirectX SDK has been integrated into Windows SDK, and certain Direct3D or DirectX locked off to only one OS than another. And the DirectX can also help with their video manager, supporting visualization of graphics hardware for applications and services like the desktop window manager. And it is also compatible with .NET Framework, which is another one of Microsoft's compatible languages, I think. Not quite sure on what .NET Framework actually is, but it's compatible with it. And DirectX and OpenGL are both graphical APIs. That's really all I've got on graphical APIs. So I've explained OpenGL and Microsoft DirectX. That's really all I have. All I'm going to say is that DirectX and OpenGL will be in a lot of games released for PC, Xbox 360. Not so much on PlayStation 4, because PlayStation 4 is not Microsoft and wouldn't use DirectX because of it being on a Linux platform, and it's also Sony. But that's all I've got for graphical API. Next up is Sound API. So next up I'll be explaining Sound API. Okay, now we are on to graphical API. Now there are two main ones I'm going to talk about. OpenGL, which is abbreviated for Open Graphics Library, and is a cross-language multi-platform application programming interface for rendering 2D and 3D vector graphics. And DirectX, which is made by Microsoft and is still used and is going to be on the next Windows. Now, OpenGL is the API is typically used to interact with a graphics processing unit (GPU) to achieve hardware accelerated rendering. Basically, all the rendering is all on the graphics card itself, not really anything to do with any software. It's all done via hardware. And applications use it extensively in the fields of CAD, virtual reality, scientific visualization, information visualization, flight simulation, and video games. OpenGL is also a non-profit technology. It's made by the non-profit technology Constructum Kronos Group. And it basically renders 2D and 3D games purely off of the graphics card itself. And a lot of games do use OpenGL. But OpenGL is an evolving API. New versions of OpenGL specifications are regularly based on the Khronos group, and it extends the API to support various new features. The details of each version are decided by the consensus between the group's members, including graphics card manufacturers, operating system designers, and general technology companies such as Mozilla and Google. So, like internet providers and search engines. In addition to the features required by the core API, GPU vendors may provide additional functionality in the form of extensions, and extensions may introduce new functions and new constants and may relax or remove restrictions on existing OpenGL functions. Vendors can use extensions to expose custom APIs without needing support from other vendors, which greatly increases the flexibility of OpenGL. All extensions are collected in and defined by the OpenGL registry. They also like multiple books, like the red book, the orange book, the green book, the blue book, and the alpha book. But I'm not going to go over those because those are basically the page on how to use OpenGL, and also like various context and window toolkits. But OpenGL itself is a interface for rendering 2D and 3D vector graphics, and it purely goes off of the GPU to achieve hardware accelerated rendering. That's OpenGL. Next up I will explain DirectX. I will now be talking about application software and interpreted languages for games. Now, there are too many programs to even explain this, so I'm going to take two out and explain those, and I'm going to use C++ because that's a programming language and it has imperative, object-oriented, and generic programming features, and Unreal Script, which is a scripting language that is used for Unreal Engine and is still used to this day. The C++, like I said, it has imperative, object-oriented, and generic programming features, but it also provides facilities for low-level manipulation. So that means stuff like physics and stuff, and C++ is still used to this day. It's even used in Unreal Engine 4, and it was pretty much every game has C++. It's cross-platform, so you will see it on PC, PS3, PS4, Xbox One, and Xbox 360, and it, it influenced um, C Sharp, Java, and newer versions of C. The C++ was developed by a Danish computer scientist, but it was mainly developed for games and for programming languages, which in late feature editions included templates, exceptions, namespaces, newcastle, and a Boolean type. But it's still going on to this. It's still going this day, and the newer version is C++ 14. But soon, in 2 years' time, there'll be a 2017 release called C++ 17. But it's used everywhere, and if you install a game on Steam, if it says installing Microsoft C++, that's to help make the game play better, even though that each game requires C++. C++ you also have to buy if you want to use it in Unreal Engine. It's one of those things that you do have to purchase. But C++ is one of the main ones that we use for object orientation and stuff like that. As for Unreal Script, Unreal Script basically is used for authoring game code and gameplay events before the release of Unreal Engine 4. But I don't know if I did say it might be in Unreal Engine 4. I'm not quite sure. The language is simple, high-level game programming. It's similar to Java, and Unreal Script is also object-oriented without multiple inheritance, which means classes all inherit from a common object class. and classes are defined in individual files named for the class they define. And unlike Java, this one is case sensitive and does not have object wrappers up for primitive types. The interfaces are only supported in Unreal Engine Generation 3 and a few Unreal Engine 2 games. This also supports operator overloading but not method overloading, except for optional parameters. Unreal Script also helped the growth of a large modding community around Unreal, which I will showcase a few Unreal mods that have been ported to Unreal Engine 3 in this video. One of them being Killing Floor. Now there are code commands, primitive types, reference types, and composite types, but with also like the functions. But nonetheless, this is a scripting way, and it's an application software, and it's been going since 1998. That's really all I have on the side of application softwares, but there are a lot of them, and I can't cover them all, so I've only covered the main two that I think do make a difference, which is Unreal Script and C++. Next up I'll be explaining Graphical API and the last two, and Sound API, and I'll see if I can get anything on television. So next up is Graphical API. Okay, Sound APIs. Now we have OpenAL and Java Sound Technology. I will start off with OpenAL, which stands for Open Audio Library, and it is a cross-platform audio application programming interface, again API, and it is designed for the efficient rendering of multi-channel 3-dimensional positional radio, so in essence 7.1 surround sound, I guess. Its API style and conventions deliberately resemble those of OpenGL. Early versions of Framework were open source software, but later revisions are proprietary. Now OpenAL, I haven't seen being used in most of my games. That's because they never actually showcase it. And it was written in C. Wait. Oh, yeah, 3D audio systems such as EAX and A3D are an open replacement for proprietary 3D audio systems. So I've used EAX because that was in Doom 3, but I'm guessing that OpenAL is a lot better because OpenAL can add realism to a game by stimulating attenuation, which is degradation of sound over distance. So actually giving the sense of distance, like if for an example, if you're playing a game and a zombie was making a sound further away, you wouldn't be able to hear that, but the closer it gets, the more sound it's going to produce, and the further you get away from it, most likely you won't be able to hear it after you go so far away. And also the Doppler effect, which is a change in frequency as a result of motion. So if you were to move, it would change the frequency, but also in the case that if you move, you will start to, if you turn like the character's head, you may only hear it through the one earphone as a part of the 7.1 surround sound. And I haven't seen OpenAL being used in any of my games, but they don't really specify which sound, if they are using OpenAL, but I'm guessing they do if it has OpenGL. I think they have a list of gaming devices the gaming devices they used it was GameCube, PlayStation 2, PlayStation 3, Xbox 360, the Wii, and the PlayStation Portable. And some of the games I've actually played do include this. One of them being Doom 3. Doom 3 was very good with this. I mean, it added a lot of different parts to it, and a lot of scary moments to it. even some simulators use it, like Euro Truck Simulator. It's purely to enhance the player's immersion in the game. So the reason they actually use this is to basically enhance it, but also as a way of making the game better, because as you get further away, the more you won't be able to hear it. So then, if you get closer, you know how close it is to make, and you can also make you move. So it's used in a lot of ways, and OpenAL is, I'm guessing, is actually one of the main ones, judging by the amount of games that use it. And the other one is Java Sound Technology, and which is Java's Sound API. And the API supports the audio file formats AIFF and AU and WAV, music file formats MIDI Type 0, MIDI Type 1, and rich music format, sound formats 8-bit and 16-bit audio data in mono and stereo with sample rates of from 8 kHz to 48 kHz, linear, ALAW, and MULO encoded data in any of the supported audio file formats, MIDI wavetable synthesis, and sequencing in software, and access to hardware MIDI devices, and all software mixer that can mix and render up to 64 total channels of digital audio and synthesized MIDI music. You can actually download the thing from their website. But again, I'm not sure if like any games use this. I'm gonna try and find out that, because I'm pretty sure they didn't. I'm pretty sure games didn't use it as much as they would use OpenAL. But the game engines that used it was Slick, JMonkey Engine, and LWGJL, which is the lightweight Java game library. But again, I don't think any modern games actually use this. I think it's just all OpenAL. Let me find it. Yeah, I think it's all OpenAL. Apart from Minecraft, Minecraft uses it because of it being on a Java platform. But I believe OpenAL is more used for because games don't really run off Java anymore, apart from Minecraft. So I think that overall the sound API for that one would be OpenAL. But I've explained OpenAL and Java Sound API to the best of my abilities. And next up is television, ITV and ETV. Okay, now the last but not least, television. There's the ITV, which is interactive television, and enhanced TV, and is an example of interactive TV. Now, interactive television is basically a form of media converging, adding data services to traditional television technology. Throughout its history, these have included on-demand delivery of content, as well as new uses such as online shopping, banking, and so forth. Now, I know there are like little boxes that you can get that was kickstarted called the Ouya, which you could link up to your TV, and you could play games off of the Ouya, but again, that would require a TV. Now, I don't know much about interactive television or enhanced TV, and I haven't found a lot about it being used in games apart from hooking up a TV, hooking up a gaming system to a TV. So I really don't have much information on this. I could try and explain it to the best of my abilities. But the enhanced TV also includes website, like a web browser to a particular program specific website that is synchronized to the live program by the broadcast TV network. Alternatively, some computers have TV tuner cards or television receivers. For examples of those with Google TV offer web browsers. So enhanced TV is to basically make it a TV but double up as a PC, depending on what you have hooked up to your TV or what your TV is, and it says here, like, it is used in particular in reference to two-screen solutions, TV plus PC services, and is an example of interactive TV. But to my from what I'm seeing, not a lot of people use. I'm not sure if a lot of people use interactive television. I mean, I do know that by hooking up a game system, you can make the television interactive. But as far as I know, stuff like the Ouya is a games console that is just primarily hooked up to the TV. And it's just a really small box with games installed on it. So really, I can't really explain interactive television and enhanced TV to the best of my abilities. But as far as I know, it's just things that can make the TV interactive with on-demand delivery and content, such as online shopping, banking, and so forth. But I can see games being used for this, and the same with the enhanced TV because of it having a web browser. Maybe soon it'll be integrated into games. So that's all I've got on TV. It's not a lot of information, but it's the best that I can do. But thank you for watching this video, and if you think I missed anything out, comment down below, and thanks for watching.